In this video, I'll be helping you with the ALEKS problem type called graphing a hyperbola given its equation in general form. And from general form, we'll want to convert to standard form. And looking at my squared variables, I can see that the x squared is the one that is negative. So we know that our standard form version will be the one with the negative in front of the x. So that'll be the second fraction here in standard form. With this as our goal, we'll start manipulating the general form to put this hyperbola in standard form. So I have rewritten the original general form, and to start transitioning this into standard form, I'm going to put my y variables first in standard form, leave some room, and then put my x variables, and this right-hand side was 0 in the original. But I do want to move any constants over to the other side, so I'll go ahead and add the 881 to the right-hand side, so equals 881. I can now start to complete the square with the y's and the x's. But first, I'll need to factor out any common factors from the y's and the x's. For the y's, I can see that there's a common 16 that I can factor out, leaving me with y squared plus 6y. Again, leaving room to complete the square. And for the x's, I'm going to need to factor out that negative 25. And that will leave me with a positive x squared and then a minus 10x since I've factored out a negative. And we still have the 881 on the right. Now we can complete the square. Half of 6 is 3, and when we square it, that's 9. So I need to add 9 to complete the square. But notice that when the 16 gets distributed, I've actually added 144 to the left-hand side of this equation, so I must add 144 to the right-hand side to keep everything equal. And then completing the square on the x's, we take half of 10, which is 5, and square it. I need to add 25 to complete the square. But when I distribute that negative 25 to the 25 I just introduced, I have subtracted 625 from the left-hand side, so I must also subtract 625 from the right-hand side. I can now see that completing the square, I have 16 times. This is now a perfect square. It's y plus 3 squared. And then for the x's, this is now x minus 5 squared. And then adding up all of these constants on the right-hand side, I have 400. And from here, for a hyperbola, the right-hand side must be 1. So I want to divide this right-hand side by 400, which means dividing each piece of the left-hand side by 400 as well. This will give me the 1 on the right-hand side. On the left-hand side, 16 goes into 400 25 times. So this would be y plus 3 squared over 25. And 25 goes into 416 times. So this would be our minus x minus 5 squared over 16. We now have our standard form. And with standard form, I can now start to graph. Since our standard form here has the y variable first, I know that that will give us a vertical transverse axis. So we will be opening up and down in this example. And I'll start by identifying the center, which is our HK. H being what is subtracted from x. So we are subtracting 5 from x. So H is 5. K being what we are subtracting from y. Here we are subtracting a negative 3 from y. So our center is 5, negative 3, which is here. And from here, I can use my A's and B's. I like to start with what's underneath the X. which here is our b squared. B squared is 16, so b is 4. And since b is underneath the x, I know from our center I will go 4 spaces right and 4 spaces left to draw that rectangle. And then looking at the other denominator, our a squared is 25, so a is 5. A is under the y variable, so we will go up and down 5 units. And from here we have everything we need to graph. We can connect these dots in our rectangle that forms the basis of the center of the hyperbola. And then going through the center and those corners will give us our asymptotes. And we know that this is a vertical transverse axis, again, because the y squared term is first. So our graph will be opening up, getting closer to those asymptotes, and opening down, getting closer to the asymptotes. So this will be the graph of our hyperbola.